All right. So anyway, like we were saying, the 45, 45, 90, knowing that in the 30, 60, 90 triangle. Some of you did fine with this, okay? If you got an A and there were several A's in here, yeah, you're in good shape. You don't need to do a whole lot more. Probably the correction will take you about 30 seconds at most. You might even less, maybe even less, and you'll be done. But some of you just don't know those identity triangles yet, and that's an issue. We've got to learn those identity triangles. Because we're going to be doing this stuff with 30, 60, 90, and 45, 45, 90 and right triangles. Everything is going to break into right triangles all year long. Whether it's octagons or even circles, whatever, we're going to break things into triangles and break the triangles down into right triangles. Because we have so many techniques of solving right triangles. They're such a powerful tool. So knowing these right triangles and being able to solve them is kind of the foundational skill for the entire second semester. For example, this is a very typical problem later in the year. It's going to be find the area of this figure. Well, the only way we're going to be able to do that is by working with our right triangles. And we have to be a little creative. We have to say, oh yeah, I could draw in that vertical line and create a rectangle and a right triangle. Oh, well, find the area of the rectangle would be easy. That'd be 12. But now we also have to find maybe the area and the perimeter of this figure, because the area actually wouldn't need a whole lot of help with, but area and perimeter. I know this side is going to be 3 down here. How long is this side over here going to be? And since this is a 45-degree angle, and this has to be a 45-degree angle because this is 90, this side is going to be, and the end here is going to be 4 root 2, because I know the pattern of that triangle. Now, the area, this would be 4 times 4 is 16 divided by 2 is 8. The area is 20 meters squared. And the perimeter is 3 plus 4 plus 7, 14 plus 4 root 2 meters, exactly. But we can't do a problem like that if we don't understand this right triangle stuff we're working right now. And like I said, that's the kind of problem we're going to be seeing later in the year, which is why it's so important. So when we look at this stuff, just reviewing again, if you don't have this memorized, take out a piece of paper, write this down, put it on a note card, do what you have to do to memorize it. But the 45, 45, 90 triangle, you've got a leg, and the third side is the leg times the square root of 2. Not times 2, not times the square root of 3, not times the square root of 5. Which, by the way, are all things that I saw on the test. But that's the 45, 45, 90. And every 45, 45, 90 triangle fits that pattern. Every single one of them. Doesn't matter how big, how small, whether it's twisted and flipped or whatever it is. If it's a 45, 45, 90, it's going to fit that pattern. The second pattern we have is for the 30, 60, 90. For the 30, 60, 90 triangle, we have the short leg. The longest side is the hypotenuse, so that's always the short leg times 2. Excuse me. Let me rewrite that. 2 times the short leg. Usually put the 2 first. And the longer leg, the middle side, is the short leg times the square root of 3. And again, that's something you just have to memorize. There's no way around that. People who did poorly on the test tended to not have that memorized. Yes? No, it'd be the 60. The 30 is up here because that's smaller. Smaller angle, biggest angle. Right? Because the shortest side always has to be opposite the smallest angle. Middle, longest. So we have to have those memorized, otherwise you're not going to do that. Now again, if you bomb this test or quiz, remember it's only a quiz. The good news is you can do a retake. It doesn't matter if you got 25% on this quiz. Well, it does at the moment. Your parents are probably freaking out. But it's okay. because you can still learn this stuff over the next week or so, make your corrections, come and do a retake, and get like an 80 or 85, 90 on the test if you really get it, if you've learned it, and I'll take that new score and throw out the old one and put the new one in there for you. So you don't have to panic if you haven't learned it yet, but some of you, I think, have started second semester just on a little bit of a, it's a snow day every day kind of idea, and it's just not working for us right now. We got to kick it into gear a little bit more if we want to be successful. And some of you are doing great, but we got to get that stuff memorized. That's going to be huge. The other thing that we still have to work on are the similar right triangle problems. And a lot of you have been resisting the idea of drawing 3 triangles, but I tell you what, the people who are being most successful are the people who are doing that. We're setting up all, in fact, I saw a student, not from this class, but from another one, they actually went on the computer and drew 3 triangles, the mama triangle, or the papa triangle, the mama triangle, and the baby triangle. Okay? They drew the 3 pictures. I know everybody in here can handle the concept of short, middle, and long. They don't. What they did is they went on a computer, they drew these 3 pictures, and then they copied several on a sheet of paper, and every time they have one of these problems, they just take out one of these little sheets that has the 3 triangles on it. So they've got a nice little thing set up, so they don't have to redraw it every time. And then they just, oh, okay, and so let's put some numbers in here. Let's say this is N, and this is 8, and this is, I don't know, 12. I'm not even sure how the numbers are going to come out here. I'm just making it up. I don't know. There's somebody in not even in one of my classes, in a different class. But I saw what they'd done. It's like, oh, that's a really good idea. And so they slap one of these on there and they say, okay, just start with a big outer triangle. Big outer triangle, what's the shortest side? That's this side here. Even if I flip this over and rotate it and twist it and stuff, it still can identify which side is shortest, right? That's the shortest side, I don't know anything about it. That's the middle leg, I don't know anything about that. The longest side is 8 plus n. I'm probably not going to have to work with that, but we'll put it there anyway. The middle triangle. Which side is the shortest side in the middle triangle? Oh, the 12 is. I know it's on the left here, but the way I drew it down here, it's shortest, middle, longest, not left, right, top, bottom. That doesn't matter. The middle side is the n. The longest side, I don't know. All right? Let's go to my third, my baby triangle. My shortest side is 8. My middle side is 12. My longest side I don't know, but that's okay. That's enough information. Now my proportion is really simple. Yeah. And over 12 is 12 over 8. And a lot of people got mixed up on a problem like this on the quiz. You did it cross multiplying. I get 144 equals 8n. But people tried to square root and stuff here. There's no need to square root. There's no squared in this case. This one's set up in a way such that we didn't get an x squared that we have to solve for. We just have n. And that's just basic algebra 1. Divide both sides by, yeah, n is 18. Actually worked well. Got a whole number. That was especially nice. Lucky for me. All right? But that's all it takes. But you have to slow it down and organize. And some of you are really being stubborn about refusing to want to draw out those triangles. And you just want to do it in your head. Why do I got to draw that up? You got to give that up a little bit if you want to be successful here. I'm sorry. It's just the way it is. Yeah, I wish we could just, do everything in our heads and make it so much faster and less writing, but draw it out. And if you want to make yourself a whole set of things like that for whenever you get problems like this, fine. And I would even be fine to go so far as say, if you have a blank little sheet like that and you want to tape it onto your test when you're doing your test, do it. If that helps you. It's not cheating. It's just 3 pictures of 3 triangles. You still got to figure everything out. Go ahead, do it. Use that if you want to. All right? I'm not going to go over specific ones because I want you to do that as part of your thing. And if you want to come in and go over stuff with me before or after school, or I'll be here after school today or before school tomorrow, and or a learning center, go over someone, that's fine. But we have a lot to get through today. All right. Let's just do this one real quick as one more example, and then let's get our new stuff because we got a lot to talk about. Again, a little different that I give you the exterior angle, but that's okay because the interior angle is going to have to be 30 because they add up to 180, supplementary pair. 30, 60, 90 triangle. Use the pattern triangle. Short leg. Hypotenuse, the longest side always is opposite the right angle, so that's short leg times 2. And the short leg times the square root of 3. Well, what do I have? I have the hypotenuse, the short leg times 2 is 4 root 2. No, because no, because 2 is, what's bigger, 2 or the square root of 3? Which number is bigger? 2 is, isn't it? Square root of 3 is only like 1.7. Don't confuse 3 with the square root of 3. They're different. And all I have to do is divide by 2. So that may be where you made your mistake. And the short leg is 2 root 2. Then this is going to be the short leg times the square root of 3, but root 2 times 3 is 3, that's 2 root 6. Which doesn't simplify, so I can just leave it there. And that's how you do those problems, by knowing the pattern. Of course you can't do that if you don't know the pattern. It's not too late to learn the pattern if you didn't know it on this quiz. It's not too late. You can still do it, do the makeup. We got probably about 4 weeks before that makeup window is going to close. So, yeah. Sooner is probably better than later, but you've got some time. Learn this stuff. Come in for help. Please, please, please. I'm here almost every day before school and after school. Today will be one of the early days, and I'm leaving at 3:20, which is still pretty half hour after school. All right. Today, trig. We're starting trigonometry. Trig really is not as bad as you might think it is. It has to do with basically creating patterns for all right triangles. We are only going to do right triangle trig in here. You can do trig with acute triangles and obtuse triangles and stuff like that, but that's for pre-calculus or the trig class, not for us. We're sticking with right triangle trig. But it's going to help us solve triangles. We're going to learn today what's called the tangent ratio. But in order to do that, we want to understand basically what's going on. Why is this trig? Why are we dealing with ratios of sides? Why is that important to us? And we can go right back to, say, 30, 60, 90 triangles. Here's a real simple 30, 60, 90. All right? This side is 2. That's the short leg. How long does the hypotenuse have to be? 4. Okay. So if I take the ratio of the hypotenuse to the short side, ratio of the hypotenuse to the short side, or let's do short side to the hypotenuse. If I take the ratio, short side to hypotenuse, it's 2 over 4, which is 1/2, right? If I have a much larger and more complex right triangle, that's a 30, 60, 90, and this side is 17 times the square root of 15, this side would have to be 34 times the square root of 15. The side lengths are different when the triangle is a different side. But if I took the ratio of the short side to the longest side, and reduced it, the root 15's canceled, and 17 over 34 reduces to 1/2. Doesn't it? So it doesn't matter how big or small the 30, 60, 90 triangle is. If I take the ratio of the short side to the hypotenuse, I always get the same ratio, don't I? 1/2. That's what trig does. Trig takes those ratios and standardizes them for every possible right triangle. Not just for 30, 60, 90, or 45, 45, 90, but if this was 61.265 degrees. There's a set ratio for the shortest side to the hypotenuse. And it standardizes that for us. Now, you don't have to memorize those ratios. That's what your calculator is going to be for. And we're going to use our book as well. You will need a calculator for this unit. Absolutely, you need a calculator that has trig functions on it. So your little blue one from middle school or whatever probably isn't going to work anymore. It just has plus, minus, times, divide, square root. You're going to need more. Now, you can download one for free on your smartphone, okay? And if you're working in class, you can always use one of the yellow ones. I've got plenty. But if you're going to be working at home for homework, you're going to want to either have one on your smartphone or have your own to work with, okay? If you're going out to buy one, talk to me about it. I'll tell you what I think is the best one to get for the cheapest price. It's this one. And it comes in a variety of colors, too. So there you go. Kind of personalize it. All right. So we need to be able to name things. Before we name things, I want you to do a quick exercise for me. Everybody point to the right. Point to the right. Okay, you guys are all pointing to the chalkboard. I'm all pointing to this wall. Which one of us is incorrect? So what you're telling me is that right is not an absolute reference. Right is relative to our point of view, isn't it? If I was standing this way, right would be the door. Okay? Right is not absolute. Right is dependent on point of view. Some of the names we're going to get today are going to be dependent on point of view. Some are going to be absolute. Point to the projector. Okay? Doesn't matter where we are. We're all pointing in different directions, but the projector is always a projector. Period. It's an absolute. It's a fixed point. Fixed reference. So that's the idea, is that some things are relative, some things are absolute. Same is going to hold in triangles. When I'm talking about right triangles, the hypotenuse is always a hypotenuse. It is a fixed reference. It's the angle across from it's the side across from the right angle. Always. It's the longest side of the right triangle. Always. The only name that side is going to have is the hypotenuse. The other two sides, the legs of the right triangle, are going to have names that are relative based on point of view, and the point of view is going to be an angle. So if this is my point of view, angle A, which we have in red here, if this is my point of view, then this side, CB, is the opposite, and this side, CA, is the adjacent. You're saying, well, wouldn't AB also be adjacent? Yeah, but AB is already the hypotenuse. It doesn't get two names. It's not greedy. Every side gets a name. If I'm talking about angle B, now this side becomes the opposite, CA, and the adjacent gets to be CB. So adjacent and opposite are descriptors that are relative to point of view, and point of view is always one of the acute angles in the triangle. So opposite and adjacent every right triangle is going to have three sides: opposite, adjacent, and hypotenuse. Hypotenuse is fixed. Opposite and adjacent will be dependent on point of view of one of the acute angles. Now, for this class, we will never talk about opposite, adjacent, hypotenuse for the right angle, because that gets very confusing. That is a topic we cover in pre-calc and trig. But we don't go, we just do very, very basic trig. We aren't going to get into complicated stuff at all. It's complicated enough, with just opposite, adjacent, hypotenuse. The tangent is simply a ratio that is defined as being the tangent of an angle is always the ratio of the length of the opposite over the length of the adjacent. And we'll only take the tangent of one of the acute angles. So a triangle itself doesn't have a tangent. Each acute angle in the triangle has a tangent ratio associated with it. So if I were to take the tangent of angle A here, That'd be the opposite, CB, over the length of the adjacent for angle A, CA. The tangent for angle B would not be the same because it's relative. Tangent angle B would be the opposite of angle B, which is CA, over the adjacent for angle B, which is CB. But that's what a tangent ratio does. Its tangent is opposite over adjacent. That's important. So if I look at a picture here, here's got some numbers. Let's throw some numbers in there. Side CB is 10, side AC is 17. What would the tangent ratio be for angle A? Okay, for angle A, again, little strategy. Always identify, here's my point of view, A. So the opposite's going to be down here, 10. The adjacent, well, this side can't be adjacent, that's the hypotenuse. Must be the 17. What if I switch point of view? Tangent of angle B. Which side is the opposite? 17 over adjacent, which is 10. What do you notice about those two? Yeah, reciprocals, aren't they? In fact, in any right triangle, in any individual right triangle, the tangents of the acute angles are always reciprocals. Always. That's the way it works. One person's opposite is the other person's adjacent.
Kind of like one man's trash is one man's trash.
And one man's ceiling is another man's floor. Apartment buildings. Think about it.
No, apartment buildings. You know what I was wondering?
No, we are not digressing. Okay? Now, how is that useful for us? Well, let's take a look at this. Let's go ahead and decimalize the tangent of angle A. And if we do that, 10 divided by 17, whoops, no. There we go. We get about 0.5882. Now, I said every triangle that has the same angles has that same tangent measure. Let's try to figure out what that angle is. We can actually look this up. Page 925 in your book. So get out your book for a second. And your calculator will do this too, and we'll learn how to do this in the calculator a little later. $925. 925. Now you aren't going to find, on that page you're going to find a table of trigonometric ratios. We're going to look in the tangent column. We're going to start reading down until we find about where 0.5882 would belong. Where would it be? Between what two angles? 31. Because tangent of 30 is 0.5774, which is, and this is more. Tangent of 31 is 0.6009. So that means it's somewhere in between. So I know this angle is between 30 and 31 degrees now, don't I? Because I know its tangent ratio, I can figure out that this angle is probably about 30.5 degrees. We can estimate. Well, that's kind of cool. We've never been able to do something like that before. If I just know the sides of the triangle, figure out what the angle is. So right away we see there are going to be lots of very good applications for this tangent. Lots of stuff we can do with that. Practice just a little bit more. Let's find the tangents of a couple angles. And some of the homework is going to be this simple. Here's another triangle. Tangent of angle A. There's angle A. Or the tangent of that angle B. Or is it 13 over 7? Which one is it? Why? Because angle A, which side is the opposite? For angle A, 7 is the opposite, right? But when I'm talking about angle B, then 13 becomes the opposite. Because opposite and adjacent are relative to point of view. But that's why I can't just say tangent of the triangle, because there are two different tangents, depending on point of view. And again, we never take tangent of the right angle. Okay? Not at this level. That's a more complicated thing for pre-calc or trig. Tangent of x, it can be done. It just says it gets messy. Okay, tangent of x, again, we have to find the angle, identify the opposite side. That's 9. So 8 becomes the adjacent. So tangent of z would be 8 over 9. So how can we use this? Well, we can use this the other way. What if I don't know the sides, but I know the angle? This is really one of the main applications of tangent. I want to know how long this side is. X. I know this angle up here is 74. Let's call this angle A. Okay? Well, what do I know about angle A? I know, well, the tangent of angle A would have to be the length of the opposite over the length of the adjacent, which would be x over 24. But in this case, I know angle A. Now, we've just seen I can find a decimal value. Tangent 74 is a fixed value, isn't it? So I could look that up in my book, or I could use my calculator to look it up, couldn't I? Tan 74 has a fixed value in my calculator. It also has a ratio value. This gets tough for people. We have to remember this has a fixed value and a ratio value. And what we're going to do is we're going to compare the fixed value to the ratio value. It's not one or the other, it's both. And we're going to use that to set up an equation. So tangent is 74. Well, let's practice with our calculator real quick. Or we could look it up in your chart. Everyone has a book in front of them right now. What do you have for tangent of 74? 3.4874. So 3.4874 is x over 24. Can I solve that equation? Oh, yeah. What are we going to do? Multiply both sides by 24. 74. Right? Gives me 83.7. And I've just found the length of that side of the triangle. Now, you're saying, well, big deal, we had Pythagorean theorem before. Yeah, Pythagorean theorem works, but we have to know 2 out of 3 sides. How many sides of this triangle did I know? 1. But I knew one angle also, and the fact that it was a right triangle. So now suddenly I found that other side, didn't I? Yes, I do. I could find the third angle very easily, couldn't I? Okay, so I have to add up to 90. Actually, 16. Sorry. Yeah.
Oh, yeah, okay.
26 would take you to 100.
Yeah.
You want to go to 90. Okay. That's not the first time.
Not the first time.
Okay. So again, we just set it up. We just so doing these problems, we just set up an equation and solve it. That's the way we solve these tangent problems. So there is a second option. The other option would be to go to the other angle. See, now you made me do it. I blame you completely. Okay? I could find that third angle at 16. Okay? So instead I could, using option 2, I could do tangent of 16 equals, and instead of setting this tangent of 16, now notice I switched the x and the 24. So this is a slightly different triangle. In fact, I'd rather keep it the same way. So I'm going to switch these back. I don't want to do a different triangle because that's going to be confusing. I want to do the same triangle. So I'm going to switch that back, okay? Tangent of 16 will be 24 over x. Now again, we could get a decimal value now. So we start by setting it up with the ratio value, then we switch this to the decimal value for tangent of 16, which we can look up. Is what? 0.2867. Now this is a little trickier equation to solve because the x is in the denominator. And instead of in the numerator, but it's really not that bad. I'll explain to you how we do it a couple different ways. All right? I could say multiply both sides by x. So x times 0.2867 equals 24 over x times x. That makes them cancel out. And then x equals dividing both sides by 0.2867 equals 24 divided by 0.2867. But what we usually do with these is because, look at this. What did we do? When the x is in the denominator, we can just swap those positions. We can just swap them. Because essentially we're doing is shortcutting the two steps. There's a shortcut you're allowed to take when x is in the denominator. Then when I take 24 divided by 0.2867, gosh, I get 83.7 again, which is exactly what we got here, because it's the same side, right? It's the same triangle. So solving triangles using the tangent ratio is pretty simple. If you're going to use your calculator, which many of you will do, make sure you're in degree mode when you do this. DEG mode. You might have to hit the mode button. If you're not sure, ask me. I'll show you. All right. We are almost out of time here, I think.
4 minutes.
We got 4 minutes still? 12:08. 12:08. Oh, yeah, we got almost 4 minutes. Oh, we're doing great. We actually got through this whole thing. Marvelous. Okay, so let's just set up one more. I want you to practice one quick one. Okay, not necessarily drawn to scale, but I'm going to say that this angle is 53 degrees, and that this side is x, and this side is 11. How could we set up to solve for x? Well, we only have one ratio to choose from right now, which is which? The only ratio we have that we're working with is the tangent ratio, right? Which angle are we going to work with? 53. So I want to take the tangent of 53 has to equal what as a ratio? X over 11. Yay, the x is on top. I like it better when the x is on top. It's easier to solve. And now I could solve that basically multiplying both sides by 11. 11 times the tangent of 53. Notice it's not 11 times 53, okay? We know tangent of 53 has a value. And whether I change it to that value before or after I multiply doesn't make a difference, but notice I'm not multiplying 53 by 11. Tangent of 53 by itself has a value. So 11 tan 53, I get 14.6. That's all it takes to solve these. And look at that. We're solving facts about triangles without Pythagorean theorem, without special triangles, but by using these ratios. We're going to spend the next week learning how to do this. We're going to do it over and over and over again. We're going to learn 2 new ratios, the sine and the cosine ratio as well. And then it's just going to matter of picking the right one. Yeah. To do it the other way, I'd have to find the other angle, which would be 37. So tangent of 37 would have been 11 over x. So x equals 11 divided by tan 37. And you still get 14.6. You get the same answer. It doesn't matter. But in general, we'll use the one we're given so we don't make a mistake like, oh, it's 26 or 16. I'm not sure. Okay, like I did. Because I was led to it. Yes. No, it's in the book. So don't forget test corrections. Test corrections, guys. Don't check out yet. Test corrections are due tomorrow, along with the homework, page 469. 3 through 14, 16 through 28, even 31. 3941 plus the vocab. I didn't get around to checking this one today because we just ran out of time, but I will check this vocab tomorrow as well. So I'll be checking 2 vocab tomorrow, plus the homework, plus the test correction. So there's a lot of stuff to check in tomorrow. If you're going to do your test corrections on your test because you don't have a whole lot to do, just please do them in a different color than what you did the original test in. Use a different color ink, or if you've already done it, take a highlighter and highlight the corrections so I can easily see the correction versus what you did yesterday. All right? I may even collect the corrections tomorrow, so keep that in mind. So I can look them over to make sure you've done them correctly. All right, just wait. Bell will ring in a minute. I just have to stop the podcast.